Welcome back, chemistry fans. Today, we are going to be talking about Unit 8, Topic 3. And so this is the last topic in this unit about solutions. We started off with molarity and how we can calculate the concentration. We then moved into solubility, the extent to which solutions can dissolve materials. Today, we're moving back into the formula. So this is just a different way in which sometimes you might find concentrations are being measured with a formula. So there are two of these formulas. One is mole fraction and one is mass percent. And I believe that we begin today with the mass percent. They're both very straightforward, very, very easy. So all you have to do is just have these formulas written down so that you can utilize them. If we look at what mass percent is, it is a concentration, but this time we're not dealing with the number of particles. We're not dealing with the mole amount. It's just what is the mass percent. Now, there are uses for having this formula in when we calculate what is the pressure change of a solution. How does the pressure differential change the more you add into it? So this is how we would use some of this material, but they've taken it off the AP test. So I'm just having you understand the formulas and not worrying about how you apply the formulas then for a second formula. So fortunate for you guys this year. So mass percent is equal to the mass of the solute divided by the total mass of the solution. So notice in this bottom part of this formula, that same grams of solute is on the top and it's on the bottom. So think of this as a sum down on the bottom that needs to be added together to get the total mass of the solution. So they're going to give you not the mass of the solution. They're going to give you each of these individual parts, the mass of the solute, the mass of the solution, and you have to add them together. So here's an example for you. In this problem, it says determine the percent composition, which is the same saying as a mass percent. It's just that we have done this for compounds. Now we're going to do this for a little bit of not individual elements, but we're going to put these molecules into solvents, so solutes and solvents. Okay. Here we go. So I've got a total, it says, of 100-gram salt solution. So that's everything that has been added in here together. And then what we're going to do is understand that 20 of those grams are just the salt. So it ends up, we have 20 on top, the solute, and then we're going to have the total solvent solution is right here for the second part of it. Okay, so if we do that math, it ends up just being 20 over 100, which ends up being as 20%, or 0.2 is what it ends up. And you multiply that by 100 to turn it into a percentage. Okay, so let's try some examples. Let's hope that I can actually use my my pen here. It seems to be fritzing out on me. I may have to pause and come back to you here. All right. One of the details that you need to remember, though, is that sometimes they're going to give you these solvent values because it's water and we don't generally measure water in grams. They're going to give them to you as milliliters. Well, for water only, it only works for water. 1 milliliter equals 1 gram. And if I had 1 kilogram, if I had 1 liter, it would be 1 kilogram of water. Then what we can do is we could convert those into moles later on if we needed to, but we need to understand that ratio right there. So that's what they've given to us in this problem. But we want to turn these into mass percents. So you're given it in moles. Let's take a view back from the old days of the mole map. So in the mole map, we have had an understanding that you can go from moles to grams or grams to moles, but we had to do it in different ways. So if we went grams to moles, we were dividing. But if we're going moles to grams, like this problem is, what we're going to do is we are going to multiply. What are we multiplying by? The weight off the periodic table. So let's do this for MgCl. Now I'm going to pause here for just a second. And I am going to go and fix my pen. I'll be right back. Okay. New batteries. Let's see if we got better results. So we go onto the periodic table and we will calculate what the weight of magnesium. It's one of these weird ones, 24.3. It's somewhere in there where it's not quite enough for us to ignore. And then there are the 34.543s for the 2 chlorines. So we're going to have to add all that together to figure out what the total mass is of that molecule. So 24.3 plus 34.543 is 34.543. And we get 93.386. Okay. So I've got my mass now and I have my number of moles. So I'm going to go moles to grams. I'm going to multiply by this. So I've got 1.9 times 93.386. And when you multiply times 1.9, you get 177.4334 grams. Okay, so remember what our task is here is to do a mass percent. So I've got one of my values, and I can take that now and I can put that down below. But what I got to figure out is the mass of 8.1 liters of water. So I need to remember a liter. 1 liter is 1,000 milliliters, and in water, that means it's 1,000 grams. So that means I have 8,100 grams of water. So that's what's going to go down below here. So now we have all the details. So I'm just going to put these values in, divided by answer plus 8,100. If we substitute all that into a calculator, we end up with 0.0214 with 2 sig figs. And then we multiply that by 100. And we get 2.1% magnesium chloride. Okay, let's do another example. Let's move down here. Same story, only this time we don't have moles, we have just grams. So we're going to do 877. It's already given to us, divided by 877, again with the liters. At this point, I would hope that you can understand this is 13,200 grams. How did I do that? Because liters, there are 1,000 milliliters. So this would be the same as saying 13,200 milliliters. And then a milliliter is the same as a gram. Okay, so let's plug all this into our calculator. 877 divided by, parentheses, 877 plus 13,200, and you get 0.0623. With percentage, you multiply by 100, you get 6.23%. Okay. Now, getting into the last formula, it is mole fraction. Mole fraction is the same exact formula, but instead of putting grams on top, grams on bottom, we put moles on top, moles on bottom. So here's the formula. It's the individual moles of solute. Last formula, it was grams of solute divided by the total moles. Last time it was total grams. So nothing has changed. It's just we're substituting moles for grams where we did on the first equation. All right, so let's see what we can do here with some practice. So in this mole fraction, oh, and by the way, on mole fraction, just like in mass percent, it could be that the solute goes on top. They could ask you for the solvent. So just be careful about what they're asking for. Is it a mole fraction of the solute? Is it a mole fraction of the solvent? and that would change what values you end up with. So here's an example problem. You've got 64 grams of sulfur dioxide, 750 grams of carbon dioxide, and they want to know what is the mole fraction of the solute, they don't say, or the solvent, so we could solve for both. So in one of them, we'll put 64 on top of the mole fraction formula. On the other, we'll put the 750 on top. So in these problems, what we're going to do, though, first is convert our grams into moles. So we have to go and add up what's the weight of sulfur dioxide, and that's what you get right here. Sulfur dioxide, each sulfur weighs 32, each oxygens weigh 16. So it's 64 divided by 64, that's 1 mole. But then for the carbon dioxide, it's a little different. Carbon weighs 12. And the oxygens each weigh 16, that's 32. That's a sum right there of 44. So I got 750 divided by 44, and that's where they get the 17.5. So I've got 17.05 moles of the solute. The solute in this case is the SO2. The solvent is the CO2. Okay, so what do we do with those two values then? Well, you're going to have to put them into the mole fraction. So again, I could solve for the mole fraction of solute. I could solve for the mole fraction of the solvent. I'm just going to choose to do the solute. So I'm going to have 1 over 1 plus 17.05. Now, if I wanted to do the solvent, it'd be 17.05 divided by 1 plus 1705. It wouldn't matter on the bottom because it's always the total. So if I'm going to calculate what my mole fraction is here, don't multiply it by 100. I do 1 divided by 1 plus 17.05. And I get 0.0554 as my mole fraction, capital X. And if you do it for the other, it'd be 17.05 divided by the 1 plus 17.05. And I would get, well, no surprise, the opposite value here, 0.945, since I've got 3 sig figs. Okay, let's go practice a couple more, and then we call it a day, and we call it a unit. And you should be ready then to take an exam next class. Okay, so these are mole fractions. So this one is already in moles. So that's okay. This one is not in moles. So we've got 3,100 grams, again, because I know that there are 3,100 milliliters. I convert those into grams. But I got to get these into moles. The weight of water is 18. So I've got 3,100 divided by 18, and that equals 172 moles. So now to find my mole fraction, I've got 1.9 divided by 1.9 plus 172. So 1.9 divided by 1.9 plus 172. And what I get is 0.0109. Make that more clear. That is my mole fraction. Let's do the same for the bottom one now. The bottom one's a little bit more challenging. Barium phosphide. So I need to go and add up the weights of these bariums so that I can convert grams into moles. Each barium is 137. Each phosphorus is 31. So if I add those together, I get 137 times 3 plus 31 plus 31, 473. So 473 grams converted to moles, I divide 867 divided by 473, I get 1.83 moles. Now my water's 23.2 liters. That means I got 20 2000, I got 23,200 milliliters. That's the same thing as 23,200 grams. I divide that weight by 18, the weight off the periodic table, 23,200 divided by 18 is 1,288.9 moles. That's a lot. So my mole fraction will be 1.83 divided by 1.83 plus 1288.9. That's a lot of difference. This is going to be a very small fraction. All right. And I get 0.00142. All right. This is everything that I wish to share with you about the two new formulas that you are going to have to be able to show some mastery of and do some calculations for on your test. Thank you so much for staying with me. I will talk with you again soon. Bye-bye.